So let's discuss basic concepts and definition of terms first before solving problems in spherical trigonometry. First is we have a great circle. A great circle is a circle whose center coincides with the center of the sphere. So if this is Earth, this is the center, and you have circles A and B having this center as their center. Therefore, these two circles are great circles. But if the center of the circle is not the center of the sphere, then that is a small circle. Now, a spherical triangle is a triangle that is enclosed by arcs of three great circles. So if this is great circle A, B, and C, therefore this is your spherical triangle. Second, the sum of two sides of a spherical triangle is greater than the third side. So that is A plus B must be greater than C, B plus C must be greater than A, and A plus C must be greater than B. Third, the sum of the sides of a spherical triangle is less than 360 degrees. So A plus B plus C must be from 0 to 360 degrees. Fourth, the sum of the angles of a spherical triangle is greater than 180 degrees and less than 540 degrees. Now, if this is your world map, then this is your prime meridian which passes through Greenwich, England, where longitude is 0 degrees. On the right of the prime meridian is east and on the left is west. So this is from 0 degrees to 180 degrees east, and this is from 0 degrees to 180 degrees west. Next is that this is our equator, which is 0 degrees latitude. Here on top is north and here on the bottom is south. And this is the North Pole and South Pole. Now this is from 0 degrees to 90 degrees north and 0 degrees to 90 degrees south. Next is that if we have a right spherical triangle where one angle is 90 degrees, we can use the Napier's rule to solve for this triangle. But if this is an oblique triangle, we can use law of sines and law of cosines for sides and angles. Now let's discuss Napier's rule. Napier's rule is used to solve right spherical triangles. Triangles with 90-degree angle. So yung formula for Napier's rule are these. No need to memorize all these formulas as long as you know these two rules and this figure. First is you have to memorize this figure here. For you to easily remember it, just draw a stick figure. Draw its body, draw its legs, draw its arms, and then draw a big circle. Again ha, draw its body, its legs, its arms, and then a big circle. Next is you have a small letter C bar. Then you write a capital A bar, capital B bar, and then small letter B and small letter A. So this has to be alternating A's and B's. So that is A, B, A, B. Okay? So if you've noticed there's no capital C, it's because in this case, we have already let angle C as the 90-degree angle for our right spherical triangle. Okay? Now, what if, for example, you have interchanged your A and B here? If you're wondering if it's okay, then the answer is yes, it's totally okay. So again, here we have our Napier circle. Draw a stick body, its legs, its arms, and a big circle. Then right here is our small C bar. Now, if you've written B bar and A bar here, it's okay. As long as you still follow the alternating A's and B's. So this is B bar, A, B, A bar. So that is B, A, B, A. Now take note, A bar is 90 degrees minus angle A. B bar is 90 degrees minus angle B. And C bar is 90 degrees minus side C. So ito sila talaga yung final answer natin, ha? Okay? Assuming that we're okay now with the figure, let's proceed with our discussion regarding the sin tan add and the sin co-op rule. So to cut our explanation short, when you say sin tan add, that is sine is equal to tangent of the adjacents. Again ha, sine is equal to tangent of the adjacents. So for example, let's choose angle A. That's sine A bar is equal to tangent of the adjacent. So as you can see, adjacent sides of A bar is B and C bar. So sine A bar is equal to tangent of B times tangent of C bar. Say for example, let's choose side A. So we have sine A is equal to tangent of the adjacent sides. And the adjacent sides of side A is side B and angle B bar. So that is sine A is equal to tangent of B times tangent of B bar. Now let's try the sin co-op rule. So that's sine is equal to cosine of the opposite. Sine is equal to the cosine of the opposite. So say for example, we have C bar. Sine C bar is equal to the cosine of the opposite. So the opposite sides of C bar is A and B. So that is sine C bar is equal to cosine of B times cosine of A. Another example, let's choose side B. Sine B is equal to the cosine of the opposite. So the opposites of side B is B bar and C bar. So sine B is equal to cosine of B bar and C bar. So if you repeat these two rules for all sides and angles, you'll get all these formulas. So let's apply everything we've learned so far and let's try to solve this problem. Solve for the spherical triangle whose parts are A equal to 73 degrees, B equal to 62 degrees, and angle C is equal to 90 degrees. Okay? So take note class, you have angle C is equal to 90 degrees. So that is, meaning to say that is a right spherical triangle. So we can use the Napier's rule to solve for this problem. Okay? So first, draw the Napier circle. Draw the body, legs, arms, and a big circle. So this is C bar, A bar, B bar. Then alternating A's and B's, so A, B, A, B. We already know B and A. And we need to figure out the values of angle A, angle B, and side C. So to solve for side C, we can use the sin co-op rule. That is sine of C bar is equal to the cosine of its opposites. So that is sine C bar is equal to cosine B times cosine A. So we have sine C bar is equal to cosine 62 times cosine of 73. So C bar is equal to 7.89 degrees. But take note, this is not our final answer because C is equal to 90 degrees minus C bar. So side C is equal to 82.11 degrees. So now we know side C. Next is we can solve for angle A. So we can use the sin tan ad rule. So that is sine A bar is equal to the tangent of the adjacents. So that's sine A bar is equal to tangent of B times tangent of C bar. So that is sine A bar is equal to tangent of 62 times tangent of 7.89 degrees. And take note class that we have already solved for the value of C bar from our previous solution. So A bar is equal to 15.11 degrees. Okay? And angle A is equal to 90 degrees minus A bar. So that is 90 degrees minus 15.11 degrees. So your angle A is equal to 74.89 degrees. Now we know the value of angle A. Last one is angle B. So to solve for angle B, we can use either sin tan ad rule or sin co-op rule, whichever you want. So say for example, let's use the sin tan ad rule. So that is sine B bar is equal to the tangent of the adjacents. That's sine B bar is equal to tangent of A times tangent of C bar. That's sine B bar is equal to tangent of 73 times tangent of 7.89. B bar is equal to 26.95 degrees. And angle B is equal to 90 degrees minus B bar. So that's 90 degrees minus 26.95 degrees. And therefore, we get angle B is equal to 63.05 degrees. So our final answers are side C is equal to 82.11 degrees. Angle A is equal to 74.89 degrees. And angle B is equal to 63.05 degrees. Now let's solve one last quick problem. A spherical triangle ABC has an angle of C equal to 90 degrees and sides A equal to 50 degrees and C equal to 80 degrees. Find the value of B in degrees. And so take note, now you have angle C equal to 90 degrees, and so you have a 90-degree angle. Therefore, this is a right spherical triangle, and we can use the Napier's rule to solve for this problem. So again, draw the Napier's rule. Body, legs, arms, and a big circle. C bar, A bar, B bar, then alternating A's and B's, so that is A, B, A, B. So we know the values of A and C, and what we're looking for is side B, and we can solve for B using the sin-co-op rule. So that sine C bar is equal to cosine of opposites. That is, sine C bar is equal to cosine of B times cosine of A, where C bar is 90 degrees minus C. So we have sine of 90 degrees minus 80 degrees equal to cosine B times cosine 50. Solving for B, we get B is equal to 74.33 degrees. So now you know how to solve right spherical triangles, and that is by using the Napier's rule. Now to solve for oblique spherical triangles, you need to familiarize yourself with the law of sines and cosines. So yung law of sines is very easy to memorize. It's just sine A over sine A equal to sine B over sine B equal to sine C over sine C, where the capital letters A, B, and C are angles, and the small letters A, B, C are the sides. For the law of cosines, you have two versions. The law of cosines for sides and the law of cosines for angles. For law of cosines for sides is cos, cosine, sin, cos. So if you have cosine of side A, then this must be cosine of angle A, then BC, BC. If this is cosine of side B, then this must be cosine of angle A, then AC, AC. Lastly, if this is cosine of side C, then this must be cosine of angle A, then AB, AB. For the law of cosines for angles, it's still cos, cosine, sin, cos, but you have a negative sign in the beginning. So it still follows the same concept. If this is cosine of angle A, then this must be cosine of side A, then BC, BC. If this is cosine of angle B, then this is cosine of side B, then AC, AC. And lastly, cosine of angle C, then this is cosine of side C, then AB, AB. Now let's try to solve one problem. Number 1, what is the value of side A of a spherical triangle whose given parts are A equal to 52 degrees 30 minutes, B equal to 70 degrees 15 minutes, and C equal to 120 degrees 15 minutes? So we can't use the law of sines here because as you can see, A, B, C are given, a known side is C, and you don't know the value of either side B or C, so you can't use the law of sines here. But we can use the law of cosines for angles instead. So we can use cosine of angle A equal to negative cos B cos C plus sine B sine C cosine of side A. Cos, cosine, sin, cos. And since this is the law of cosines for angles, we have a negative sign in the beginning. So angles A, B, and C are known. A known side is side A. That's one equation, one unknown. Solving for side A, we get 57.36 degrees or 57 degrees 21 minutes. Now let's learn how to solve an isosceles spherical triangle. So an isosceles spherical triangle is a triangle that has two equal sides. If these two sides are equal, then these two angles are equal as well. So for example, we have this problem. Solve the remaining side of the spherical triangle whose given parts are angles A and B are 80 degrees and sides A and B is equal to 89 degrees. If this is our triangle, this is 89, 89, 80, and 80. So what we're looking for is this side here, side C. So what we will do is that we will divide this triangle into two triangles. So this angle here is 90 degrees and this is C over 2 and C over 2. So let's redraw our triangle. This is angle A, so let this be side A. And this is side B, so let this be angle B. And this is angle C and side C. So since we have here a right spherical triangle, we can now use the Napier's rule to solve this problem. And if you've seen my video regarding the Napier's rule, I've taught you how to draw the Napier circle. So that's draw a stick body, legs, arms, and a big circle. And assuming that angle C is 90 degrees, then we will put here small letter C bar for side C, then A bar, B bar, then alternating A's and B's, so A, B, A, B. Take note ha, we don't have capital C in the Napier circle because we assume that angle C is the 90-degree angle. So this is our Napier circle. But for this problem, let's do a minor division for a Napier circle. Because in this case, in our problem, we let our angle here, angle B, be the 90-degree angle. So our revised Napier circle is B bar. Why B bar? Because angle B is our 90-degree angle, so we have to put B here. Then A bar, C bar, then AC, AC. This is rather C over 2 since this is C over 2. So this is our revised Napier circle. So I hope you don't get confused with our Napier circle ha. Basta my point lang is that we let this as B bar because angle B is our 90-degree angle. Okay? So yeah, this is our Napier circle. So we know the value of angle A and side B. Unknown is side C. So we can use sin tan add rule for this one. Sin A bar is equal to tan B bar tan C over 2. So that's sine of A bar is equal to tangent of its adjacents. So we have sine 90 minus 80 equal to tan 90 minus 81 times tangent of C over 2. So C over 2 is equal to 84.26 degrees. Therefore, C is equal to 168.52 degrees, or that's 168 degrees 31 minutes. Now, I want you to solve this last problem to check if you've really understood the discussion. Determine the value of angle B of an isosceles spherical triangle ABC whose given parts are B equal to C equal to 54 degrees 28 minutes and A is equal to 92 degrees 30 minutes. So the answer is angle B is equal to 41 degrees 55 minutes. So you can pause the video and solve it on your own. So pause the video. Okay na? Sige, so this is our solution. B and C are both 54 degrees 28 minutes. Side A is 92 degrees 30 minutes. We know all three sides and we only have to solve one angle. So we can use the law of cosines for sides in this problem. That is cosine B is equal to cos A cos C plus sine A sine C cosine angle B. So cos cosine sin cos. If this is side B, then this here must be angle B, then AC AC. So we know the values for B, AC, AC. Unknown is angle B. That is one equation, one unknown. So cosine B is equal to cos B minus cos A cos C all over sine A sine C. Solving for B, we get 41.75 degrees. Now let's learn how to solve for the area of a spherical triangle. So itong topic na ito, it's more on direct substitution. As long as you know the formulas and also of course given lahat ng angles and radius, then yun, direct substitution na lang. Okay? So the formula for the area is pi r squared E over 180. Where E is the spherical excess and that is equal to the sum of the three angles minus 180. So for example, calculate the area of a spherical triangle whose radius is 5 meters and whose angles are 40 degrees, 65 degrees, and 110 degrees. So area is pi r squared E over 180. E is the sum of the three angles minus 180. So that is 40 plus 65 plus 110 minus 180. So that is 40 plus 65 plus 110 minus 180. That is equal to 35 degrees. So area is equal to pi times 5 squared times 35 all over 180. Therefore, our area is equal to 15.27 square meters. In this video, we will solve two problems. In the first problem, we will learn how to get the time difference between two locations. And in the second problem, we will learn how to solve what time is it problems in spherical trigonometry. So problem number 1, if the longitude of Tokyo is 139 degrees east and that of Manila is 121 degrees east, what is the time difference between Tokyo and Manila? So how do we determine the time difference? So step number 1 is that you have to know the longitudes of the two locations. So quick recap lang, longitude is the imaginary vertical line. So at the prime meridian where Greenwich, England is located, the longitude is defined to be 0 degrees. Now to the right of the prime meridian is east, while to the left of the prime meridian is west. Okay? Now let's try to plot our problem para at least ma-imagine. Say for example, this is our prime meridian, 0 degrees longitude. So right now, we are facing the east side of the globe. So if the longitude of Tokyo is 139 degrees east, meaning to say, if this is the prime meridian, 0 degrees, you have to move 139 degrees to the right, that's going east. So somewhere along this line is Tokyo. Okay? Next is, if the longitude of Manila is 121 degrees east, meaning to say, from the prime meridian, you have to move 121 degrees to the right, going east. So over here, you have Manila. Okay, so step number 2 is to get their distance apart in terms of longitude. That's distance is equal to 139 degrees minus 121 degrees. That is equal to 18 degrees. And step number 3 is to convert. So if the Earth is 360 degrees and in a day we have 24 hours, so 360 divided by 24, that is 15 degrees per hour. That means to say, in every 15 degrees, that is 1 hour time difference. So 18 degrees divided by 15 degrees per hour, that is equal to 1.2 hours. Meaning to say, Tokyo and Manila have a time difference of 1.2 hours or 1 hour and 12 minutes. How did I get 12 minutes? Pwede sa calculator or 0.2 hours times 60 minutes per hour, that is equal to 12 minutes. Hence, 1 hour and 12 minutes. Okay? So next, problem number 2, we will learn how to solve what time is it problems in spherical trigonometry. So the problem is, if the time is 8 a.m. GMT, what is the time in the Philippines which is located at 120 degrees east longitude? Now, GMT means Greenwich Mean Time. That means to say that at Greenwich, England, the time now is 8 in the morning. The question is, if it is now 8 a.m. in Greenwich, what time is it now in the Philippines? So step number 1 is that you have to know the longitudes of the two locations. Now, Greenwich, England is located on the prime meridian. So its longitude is 0 degrees. Because again, longitude on the prime meridian is 0 degrees. Okay? Next is the Philippines is at 120 degrees longitude. So if we are to graph that, it will look something like this. This is Greenwich at the prime meridian, 0 degrees. And this is the Philippines at 120 degrees east. Step number 2 is to get their distance apart in terms of longitude. So that is simply their distance apart is 120 degrees. From 0 to 120, that's 120 degrees. Step number 3 is to convert. Again, the Earth is 360 degrees and in a day we have 24 hours. So that's 15 degrees per hour. So every 15 degrees longitude, that is 1 hour time difference. So 120 degrees divided by 15 degrees per hour, that's 8 hours. So 8 hours is the time difference between Greenwich and the Philippines. And last step, step number 4, is to add or subtract the time difference. In this case, we have to add. That is 8 a.m. plus 8 hours, that is equal to 4 p.m. Meaning to say, if it is 8 a.m. at Greenwich, it is 4 p.m. at the Philippines. Question, why did we choose to add? It's because the Philippine time is advanced or way ahead of the Greenwich time. That is why we have to add 8 hours because the Philippine time is advanced. But if the question is the other way around, say for example, you are asked this question, if it is now 12 midnight in the Philippines, what time is it now at Greenwich, England? So take note ha, we have already computed that the time difference between these two is 8 hours. So the question now is, should we add or subtract the time difference? We have to subtract because we are looking now for the time of Greenwich and Greenwich time is way behind the Philippine time. So you have to subtract. So 12 midnight minus 8 hours, that is equal to 4 p.m. Meaning to say, if it is 12 midnight in the Philippines, It is 4 in the afternoon at Greenwich, England.